Hey, John.
Hey George, is your how's your web recorder doing?
Yeah, this is great. Amazing new technology. I guess it's not that new, but this is the first time I've tried it. So,
Yeah, the BHT TV web recorder. For
yeah, it
such a
seems to be
shoestring
working.
operation, they've got some pretty impressive stuff.
Well, it's really become more advanced,
Hmm.
over the years.
Right, but they still have anachronisms like us.
Yeah, yeah, it's true. And I still fondly think of it as GarageBand television.
Oh, yeah, definitely. It's funny. I've got some colleagues at Stevens who they keep saying that they want to start some kind of webcast, and like a video blog of some kind. And
Yeah.
they almost always say, and we don't want it to be too fancy. I mean, fancier than blogging heads, of course, but
Yeah, but that's part of the funky charm, I think.
right.
At least I like it. If it were any fancier, it would be too intimidating, and we'd have to wear makeup and things, and we might have lots and lots of viewers, and it would put on so much pressure.
George and John in makeup. That's something to imagine.
Well, I'm sure you've experienced it a few times, like I have.
Yeah,
Like when I was on Colbert, and when you were on Charlie Rose, and
yeah. It's weird because I don't know about you, but there have been some times when I've done shows like that, and in some cases they have really fancy equipment. They airbrush on the makeup. They've got little
oh,
machines for doing it.
I didn't run into anything that advanced.
Yeah, and and then I forget I've got it on, and then I get out of these shows and I go back out into the world, and I'm all relieved, and I might go back to my office, and
Yeah,
then people are looking at me like, "What the hell? You look weird, man." And
yeah,
then,
yeah.
and then
Well, they think you look you look realer than life.
right,
Like those people on television.
yeah, or like, yeah, you look better, but in a kind of creepy way.
I guess the last time I did that, is it NBC Morning News or CBS Morning News? Which is the building they call BlackRock?
I
But
I
you
think
know,
that's
one of these old
CBS.
dinosaur TV networks, and I'd written a piece for National Geographic magazine, and I guess someone from the show calls National Geographic and say, "Hey, can we get this guy on for a few minutes?" So amazingly, National Geographic flies me all the way from Santa Fe to New York City, and then the show puts, I guess the show paid for the flight and the hotel, and then I get up at the crack of dawn and go there, and they put on the makeup, and then I'm on for about 3 minutes, and
Right.
and then that was that. So
It's all brand building, George.
yeah, right.
Yeah.
I
Are
refuse to be a
you? How do
brand.
you feel when you do those things? Are you cool, or do you get? I mean, do you get uptight?
I I get very, I get not very uptight, but I get pretty uptight the night before, and then the morning before, and then once I get there and kind of get into the green room and the makeup and all of that stuff, then I just kind of surrender to the inevitable.
that's,
I think
that's a
you feel
nice way.
like a prisoner on death row. Maybe finally, I've had my last meal. In this case, a cardboard container of coffee, and then they lead you in, and then suddenly you're just like talking to these other talking heads, and it's over very quickly. I like radio much better.
Yeah, I find it a very almost an hallucinatory experience.
Yeah.
I also get very uptight in advance. I mean, especially before I'd really done it. I mean, back in the early '90s, every now and then, when I was a writer for Scientific American before I'd had a book published, I would occasionally be asked to do something, and I wouldn't be able to sleep sometimes
Yeah.
for nights before it happened. I'd get really progressively more and more uptight. And then sometimes it would happen,
Mhm.
and it would be this kind of blur. and then it would be over before I knew it, and I'd feel this huge rush of relief.
Yeah.
But there's something about the way that the self is situated compared to the rest of the world when you're on TV, or to a lesser extent on radio, that is very peculiar and unsettling.
Yeah, and especially TV, where the cameras are on you, and then you're like sitting at this desk in the case of the morning news show, and there are these two larger than life looking anchors, and
right, looking skeptically at you. I mean,
looking
in some
skeptically at you, and doing
right.
happy talk in between, and it's just very surreal.
Yeah, in some cases, obviously, the producer might have read a little bit of your work and enough to converse with you.
Yeah, maybe.
But then you're on with this. This happened a lot when I was on a tour for the End of Science, because I was on all these shows where the people who interviewed me clearly had no idea who I was or what kind of book I'd written. They had a list of questions, and they're looking at me like, who the hell is this guy anyway? And what is he doing here?
Yeah.
And making that very clear. And but then and this is before camera, and then camera comes on and they go into their professional mode, but I'm still sitting there, just this
right in the same old John mode, and
right. Yeah.
And then they ask the questions that the producer wrote, and I mean, the only one I really can say I enjoyed was when I was on Stephen Colbert's show, and the thing in the end where he has an author for like a few minutes, and that was great fun.
That's to me, that's one of the high points of modern television. George Johnson on the Colbert Show.
Thank you, John. It was the high point
I'm
of
not
my
kidding.
life.
That was great.
Yeah, it hasn't been as good ever since 6 minutes. And
well, you got to just be grateful.
Slowly.
You got to be grateful for the moment in the spotlight.
Yeah, and now the show's gone, sadly.
Yeah. Well, maybe he'll have you on his new show.
Oh, that would be really unexpected.
Well, but then you won't have to deal with in addition to the hallucinatory quality of being on TV in general, on Colbert, you have to deal with this double persona that he has.
Right. I've probably told this story before, but it's really great when in the green room at Colbert waiting for all this, and then he comes in and introduces himself to you, and he basically says, well, you've seen the show, right? And, oh yeah. and then he I don't even know if he asked that, maybe the producer asked that, but then he describes his whole shtick, that there are two Stephen Colberts. There's the real Stephen Colbert who's talking to you right now, and as you can see, seem to be a pretty nice, regular, reasonable guy. And then there's the Stephen Colbert character that I play on the show. And he's basically an idiot, and you have to try to educate me.
Right.
And I just thought that was very, very cool the way he did that. So
yeah, that's interesting that they would do that.
I mean, it's kind of humble in a way. I don't know, just as if anyone didn't know what the show was.
Yeah, right.
Yeah.
Well, he comes across that way. The guy I think he's brilliant. I think he's a real, I mean, if it's okay to use the term genius to describe a television personality, I think he's right up there among the most intelligent people on television right now.
Yeah.
Because, he's got this irony in the way that he presents his topics that actually is more appropriate than treating them straight very often.
And the timing is just, he's just, the whole improv thing that's really what it was. Nothing was scripted and.
Yeah. Well, yeah.
Anyway, enough of this reminiscing about.
Right. Well, so I figured I've been to some really interesting conferences lately. As part of this. I've become, I've always been interested in the mind-body problem, but I've become increasingly obsessed with it lately, over the past couple of years, and it's been kind of accelerating. And it turns out that right across the river from me. Here I am in Hoboken, right across the river, 10 minutes away by path, is NYU, which
Yeah.
has some of the greatest philosophers of mind, cognitive scientists, neuroscientists in the world.
Sure. Yeah. Yeah.
And David Chalmers runs this big center. David Chalmers, the philosopher of mind, who coined the term the hard problem to describe
Right.
the
Right.
mind-body problem. He runs a center over there, and he's probably doing this all along. But I've just recently become aware of these events that he's helping to organize
Hmm.
on the mind-body problem. So I thought I've written about for my blog, and
Yeah, I read that.
and we could start by talking about that, and then I'll
Yeah,
tell
let's
you.
talk about that because it's this theory of consciousness, right? Called integrated information theory.
Yes, and it's related to something we've talked in the past about the interest of some very serious people in panpsychism. This
Yeah,
ancient,
that's Chalmers, right? He's like one of the main
yeah,
proponents.
Chalmers and Christoph. I'm going to pronounce it Koch, but I've heard it
Okay.
pronounced Koch or Koch. Anyway,
Yeah.
Koch. One
Only
of
he
the
knows
one of
for
the
sure. Yeah.
one of the leading neuroscientists
Yeah, people with that
in the world.
surname tend to come up with non-standard ways to pronounce it.
Right. Um, anyway, so
Does Christoph still have purple hair or
no,
green
I think
hair?
his hair is very short.
Oh, okay.
Right. So let me just back up and
Yeah,
give the
sorry.
background on this. There's a theory called integrated information theory. It's about, I think, 10 years old. It was invented by a guy named Giulio Tononi,
Yeah.
who is a neuroscientist. I think he also has an MD in psychiatry.
Hmm.
He's a really smart guy. He trained under Gerald Edelman, the late
Oh, yeah,
the
yeah.
late neuroscientist and Nobel laureate, who also had a very ambitious theory of mind that you and I have talked about as
Oh,
well.
yeah, I think we got into that last time. Or
Yeah.
maybe not, but yeah.
And Tononi,
Darwinism.
yeah, neural Darwinism, and Tononi studied under Edelman and then came up with his own theory, integrated information theory, which says, and I've been reading about it for years,
Hmm.
and never fully understood it, and but the basic idea is that consciousness is a product of, or in some way is identical to, a property of any potential system, not just brains, but any physical stuff. It's a property of that describes the integration of the information processing in the system. So, in other words, you've got in a brain, you've got information processing going on in lots of different regions in the brain, and also all those regions are constantly interacting with each other in these
Yeah.
complicated feedback loops.
Right.
And Tononi came up with some kind of mathematical way to quantify that degree of integrated information in a system. And he says that the level of integrated information in a system is proportional to the consciousness of the system. And that's the basic idea. But then it immediately starts getting really complicated when he talks about how that works out in real world systems.
Mm-hmm.
And one of the problems is that it implies that pretty much any system could be conscious, because even a proton consists of three quarks that are all interdependent and constantly communicating with each other, if you want to use that term, and they produce this emergent phenomenon called a proton or a neutron.
Right, yeah, an emergent phenomenon by interacting. And part of the idea that I gathered from your column was, like, if a system can be simply reduced to being a sum of its parts, then it has a pretty low measure of consciousness, or what he uses the variable phi, right?
Right, phi.
If it has relatively low phi, and to the degree that it cannot be simply reduced to the sum of its parts, it has, what people, use the jargony term synergy to describe. I don't think he necessarily uses that, but if it has a certain level of the synergy, kind of this irreducibility, like you can't break it down into simply its parts, then it has higher phi.
Exactly.
And then if you use this, you can show that the cerebrum, the frontal cortex, which is supposed to be the seat of consciousness and thought, has higher phi than the cerebellum, which is involved in motor activities.
Yes. And
so far so good. But
yeah, and I've read popular accounts of this. Carl Zimmer had a nice piece in the New York Times, I think, in 2010. Christoph Koch has had a whole bunch of pieces in Scientific American and elsewhere, and he and Tononi have also teamed up recently and produced a bunch of overview articles on IIT. But I was still confused about it, and so I got very excited when I heard that Chalmers and Tononi were organizing this workshop at NYU a few weeks ago, and they were going to have both proponents of the theory, including Tononi and Koch, and some skeptics. And although almost all the people there were pretty sympathetic to the theory, but there was one really hardcore skeptic, a guy from MIT, a computer scientist named Scott Aronson.
Oh, Scott Aronson, yeah, he's a great skeptic of many things, including some claims about quantum computing.
Well, I hadn't realized that before I started reading his blog posts on IIT, that he's got kind of a following as a scientific skeptic who, unlike myself, for example, actually knows the technical details of the things he's criticizing.
Yeah, no, he's pretty amazing.
Yeah, he's really smart in computer science and physics and mathematics and pretty much anything he sets his mind to.
Yeah, and he's willing to put himself out there and in a polite way and question these things.
Right. So the meeting was fascinating. Another person who was there was Max Tegmark, who is a physicist at MIT who's really into multiverse theory. Yeah. And he had a recent book that argued that, I didn't read it, but reading about it, I think the theme was that the universe is mathematical, fundamentally. Yeah. It's a kind of Platonic view of the universe.
Yeah, no, it's not just that mathematics describes the universe, but it is mathematics. It comes from mathematics.
And apparently, I think at some point in his book, he talks about integrated information theory and seems to embrace it.
Yeah.
And so he was at the conference also, and I came to it hoping that I would understand the theory better, and I came away being even more mystified by it.
Yeah, I mean that seems to be the common experience, right? I mean, there was this great quote in your column from Tononi saying something about how, it's one of these things that takes a while to seep in.
Right.
Yeah.
He said he normally gives a 5-hour seminar to people to try to get them to understand the theory.
Yeah.
But in my case, I put in, I don't know, like 16 hours at this meeting, and I had read a lot of articles beforehand, and I still came up with, I still came away with some very serious doubts. I mean, more than doubts. I just don't think that the theory is going to make it.
Well, it's I mean, anything like that. I mean, if it takes a while to seep in, and I don't know, you're kind of hoping that for something as important and deep as consciousness, there'll be this theory that, once someone comes up with it and you hear it, you'll go, my God, of course. It suddenly all makes sense. But then this is consciousness, which is a whole nother level of description from what, we're used to being conscious beings describing other things and then taking consciousness for granted. But, this objection that you wrote about in your column from Scott Aronson seems to be a really interesting one where he just described how he could easily construct, on paper or even, with a soldering gun and electronic parts, a fairly simple network of simple electronic components doing something. What did he like running error correction algorithms?
Right.
And you could show that this would have maybe 10 times higher phi, higher consciousness than the human brain.
Right.
So, what does this mean? Do we take this as like a counterintuitive prediction of the theory that we have to embrace and look at this little box on the table and say this is more conscious than we are? And one of your commenters had some great thoughts on that. Like, what do we mean by more consciousness? Is it more intense consciousness or, more conscious of more things or what?
Well, I actually don't have, I see consciousness as on a spectrum. I have no problem with that. The problem that I have with IIT is that when they're confronted with some of these, so what Aronson is trying to do is come up with a reductio ad absurdum argument that, here's a consequence of your theory based on your mathematical definition of phi that I think is absurd. Yeah. And the problem is that Tononi and others just say, well, maybe that simple grid is conscious.
Yeah,
And why wouldn't they say that if they say that maybe a proton is conscious? And as I mentioned in my piece, there was actually a little side discussion at one point. This is when people were getting a little punchy, I think, over whether dark matter or dark energy, whether a perfect vacuum in space could be conscious, even if it doesn't have any baryons in it. Yeah. And Christoph actually had the comment, "Let's not be baryonic chauvinists here." I mean, he was kidding, but
well, you have virtual particles seething in the vacuum, right? From quantum fluctuations.
Yeah, but the problem I have is that what do you do? How do you falsify the theory then? If you just are supposed to accept all these wild implications,
the counter. I got the impression sort of the flavor of their objection to that was like, well, yeah, it makes strange counterintuitive predictions, but hey, look at quantum mechanics and special and general relativity.
That's true, and listen,
like a whole order of weird higher.
And and that's a good response to my bafflement to the obscurity of the theory too. I mean, I can imagine what it would have been like to be a science writer 100 years ago when you're hearing reports of first quantum mechanics and then relativity, these extremely esoteric mathematical dense theories that only initially a few specialists in the world could understand. Right. You just kind of have to take it on faith.
And yet,
yes,
it seems like very, very, very quickly, people, science writers working with scientists and science writers who were scientists came up with, fairly intuitive ways to get special relativity across, and general relativity with, metaphors like, curved space-time being like the trampoline with the medicine ball on it, deflecting it, and which is, kind of a weird metaphor because you're explaining gravity that way, but you're already presuming the old-fashioned view of gravity that's pulling down the fabric of the trampoline when it has a weight on it. But anyway, ways came where you could kind of, grok it.
Right.
The same with quantum mechanics. You would appreciate Feynman saying, well, nobody really understands the meaning, but you could say, yeah, but, you could really, sort of see how, what they were saying.
And here's another pretty fundamental difference. Yeah, I think a huge difference is that those theories in physics made very specific predictions, which were then borne out in spectacular fashion over a period of decades, and they have continued to be borne out. When you have a theory of consciousness, you are coming up against what I called in my column the solipsism problem, which it's an ancient problem in philosophy. Anybody who contemplates consciousness immediately recognizes that the only consciousness you really know exists is your own.
Yeah, right.
And any other, you're only inferring consciousness in any other system from the behavior of that system, including humans or laptops or raccoons or bats or whatever.
Just anyone. It's a hypothesis you get a lot of support for.
Yeah, and so that's one problem. Another problem I had was with the terminology employed by Tononi and other proponents of this theory. So I've always had a problem with people who say that maybe information is a fundamental property of the universe, which is what they're saying. It's what Chalmers was saying more than 20 years ago, and I had a problem with his theory of consciousness back then, which also postulated information as a fundamental property along with matter and energy.
Yeah.
Because usually these definitions go back to Claude Shannon, the inventor of information theory, and the way I understood information theory, and I actually talked to Shannon about it and read a lot about it, trying to understand it about 25 years ago, is that information is something that reduces your uncertainty. Ultimately, I mean, Shannon had a mathematical definition, but if you're trying to put it in qualitative, everyday terms, the amount of information in a system is proportional to its ability to resolve uncertainty in a receiver of some kind.
Yeah, right.
Right?
So,
and so to me, that means that there's consciousness embedded in the concept of information. So what bothers me is if you have a theory trying to explain consciousness, you can't explain it with something that already has consciousness built into it. You're trying to say why is it, where does consciousness come from in the first place, and why do we associate it with certain physical systems and not with other systems? And it just seems cheating or circular reasoning to say it all has something to do with information.
But information itself is defined as not having any semantic content.
Yeah,
it's really more of a measure of structure, isn't it? So there's different ways to think about information, but I think it was Gregory Bateson who described information or a bit of information as being the difference that makes a difference.
That's
so in whatever context it could be, something is here or there, or it's 1 millimeter this way or 1 millimeter that way, or black or white or red or blue or something. It was just the tiniest little amount of difference or distinction. And, you could argue that all of our definitions of matter and energy and space and time, at their core, they assume something like information.
Yeah.
I think that's the argument.
I don't know. This is sort of an intuitive feeling of uneasiness that I have at the way information is used in some of these theories, and I'm left dissatisfied. And I should mention that
me too.
John Searle, the great philosopher of mind, he wrote a pretty tough review of a book by Christoph. Christoph wrote a book called Consciousness: Confessions of a Romantic Reductionist. I think that was the subtitle. And Searle wrote about it in the New York Review of Books, and basically it was just a review integrated information theory. And Searle also said that information makes no sense lacking something to be informed. And so he found the theory
Yes.
incoherent.
Well, he's pretty much with you on that. As far
Yeah.
as looking at information as requiring requiring a receiver. But Searle too. He's kind of suspect in anything like this because he comes from this very strong minority of philosophers who basically doesn't believe that the brain's working by processing information. Isn't that right?
Well, the way I've always understood
his objection to artificial intelligence, the Chinese room experiment, which some of our viewers will know what that is, but it's to me it really kind of misses a lot of the and not just to me, but to people who work in artificial intelligence and cognitive science, thinks that it really misses the whole basic idea.
Well, I guess what I'd have to say is that I agree with Searle when he agrees with me. So,
and Searle understands all of the objections to his argument, I should say, and encounters them, from his own perspective. But it's almost like two people, it's just like two groups of people that are in these little sealed off, immiscible worlds. They just don't, they talk at each other, but it doesn't really, information doesn't get across. And
well, here's another problem I have just with the basic terms of the theory, the word integration. I mean, it seems to me that you have to have a lot of you have to make a lot of assumptions about a system to come up with to calculate its amount of integrated information. First of all, if you're just looking at a brain, where exactly is the information? What counts as information? How is the information encoded? We don't know the answers to any of those questions. Also, what do you count as integration? I mean, we look at the brain and we are making assumptions about the circuitry, and there seem to be some very obvious kinds of feedback effects within the brain, but we still are in a very primitive state of knowledge where we don't really know where exactly the information is embodied and what kind of integration or interaction between the different parts of the brain is really vital to consciousness.
But I think it's kind of meant to be a higher level theory, much higher level of abstraction, just saying, somehow information is encoded in structure, like the structure of a web of neurons and the frequency, the rate of the pulses between the neurons, the contours of the network and all of that. You can just kind of, stipulate that information is embodied in there somehow. And, one of my impressions after reading, which I just thought your column laid it out, very clearly, for someone like me who just kind of was vaguely aware of the theory. I first ran into Tononi in the, I guess it would have been in the early 2000s when it was this conference at George Mason University where my friend Jim Olds, a neuroscientist there, had gotten funding for something he called the Decade of the Mind.
Right.
And this was the first of the conferences. After, they'd already done Decade of the Brain. And so now that was solved and out of the way, do the Decade of the Mind. But anyway, it was a good conference. And Tononi was there presenting either integrated information theory or some close precursor. And I didn't really understand it then and kind of tuned in and out over the years. But I really felt like I got a good sense of it from your column. But what kept being struck by was what he was describing to me was more like a measure, like phi not being so much a measure of consciousness, but a measure of complexity.
Yes.
So it's no question that the brain, the cerebrum of the brain, I think few people would dispute that it is more complex as far as interconnectedness of neurons and things in the cerebellum.
Right.
And measuring. And when you talk about how something can't be reduced to its parts and irreducibility, this is one of one of the is it Kolmogorov definition of complexity, incompressibility.
Right.
And maybe this is a little different, but so I could see how this is, you're describing systems. You have a way to measure their complexity, and but then I don't see that it follows that that's necessarily consciousness. Although, I would think that a brain that's more complex than another brain is going to, arguably have a higher level of consciousness, like a human compared to a bonobo, compared to a hamster. But
yeah, I mentioned in my piece that some of there was a lot of wrangling at this workshop, which was, there were a whole bunch of scientists, there were computer scientists, there were neuroscientists, and there were a lot of philosophers. And the irony was that I found the philosophers harder to understand than anyone, because they dealt in abstractions that were very specific, obviously had great meaning for them, but for an outsider like myself, were quite obscure. But there was all this discussion about, what is the information, what is the integration, and Tegmark, for example, presented a whole bunch of alternative measurements or formulas for calculating the phi of any given system. And as I mentioned in my column, it reminded me a lot of the kinds of discussions that people had at the Santa Fe Institute when they were trying to come up with a good mathematical definition for complexity.
Yeah, right. Yeah, there's dueling definitions. Right.
Yeah, and ultimately, I think it was Seth Lloyd of MIT who came up with at least 40 different definitions of complexity,
right.
And which was a sign that the field was having a hard time grasping or getting a really good focused look at what it was trying to study.
Yeah. In like Seth's definitions, this stuff all comes down again to definitions of information.
Right.
And what we mean by information and how, like in Shannon's formula, information is related to entropy.
Right.
And depending on how you look at it, it's related to entropy or the inverse of entropy, negentropy, which intuitively feels nice, that entropy being disorder, and you'd like to think that something that's more disorderly has less information than something's very orderly does, like the brain. And yet the definition comes out to be pretty much the opposite, because, like if you have like a random sequence cannot be compressed,
right.
and to be any shorter than it is. And, the way they explain this, I think it was the Kolmogorov and Gregory Chaitin, and this idea of algorithmic complexity. So if you can write a computer program to express something that's smaller than the thing itself, then you've compressed it. So like if you have a large number, 1,000 digits long, but it turns out that it's you can factor it into, say, 3 smaller factors, and then you could just make a formula saying this factor times this factor times this factor equals this much larger sprawling number. Then you've reduced the complexity to your with your algorithm. Or if you have an infinite sequence of 2 4 2 4 2 4 2 4, you can just come up with a or say it goes on for a million iterations. You can just have a formula or an algorithm that says repeat 2 4 1 million times.
Right.
So you've compressed it. But if you have a long number that's prime and that's also random, then the only way to do it is to write a program that says write this number and then give the number. So you haven't been able to compress it. So therefore it's of higher complexity, and yet it's random. And the stuff with order is reducible to incompressible, and therefore has less complexity, except that it probably doesn't.
Right.
Because the brain would be more compressible than an equal amount of randomly scattered. Take the same atoms that make up a brain, or the same molecules, whatever grain you want to look at it, and jumble them all up into the same volume, and that would require a incompressible description or less compressible description than a description of the brain itself, since it's organized.
You
So,
know,
God, I don't know. It's just so.
well, the paradoxes seem to multiply, and this is what my impression of this workshop here was too. Even though almost everybody there was on the same page and was sympathetic, except maybe for Scott Aronson.
Yeah.
There was this growing frustration with the slipperiness of the basic concepts. And I should say, trying to put this in a more rigorous quantitative way, that Aronson pointed out that that to calculate phi for any given system, certainly for the human brain, is a NP.
NP hard.
NP hard problem, which means that it can't be calculated. You have to fall back on approximations.
Yeah. Huh. That's interesting.
To get some kind of estimate.
So it's intractable to like.
Yeah, it's an intractable problem,
Yeah,
which I found, which I loved on an intuitive level.
Yeah, right. I mean, you would hope the brain would be intractable on some level, but this is also interesting. And in this, what you're talking about before about information and whether it requires some, consciousness to perceive the information. I mean, that's such an interesting basic question. I mean, we parse the universe, into these units, atoms and subatomic particles, and in biological systems, we parse them into molecules working together to make large biomolecules working together to make cells. And there's just all this question of, how do you think about the parsing? Is it something we're imposing by our brain, with our brains, or is it actually in the system? So, I mean, I just always get this eerie feeling when I think about a human cell or any kind of biological cell as it's going about its various activities, and say including dividing, where it divides, its DNA basically is sequestered into two different little corners of the cell. The cell splits, and then you have two daughter cells with the same genetic content, and then the genetic content is, read by the messenger RNA and the ribosomes and cranks out proteins, that basically do the work of the cell. That make it an eye cell or a hair cell. Well, those are bad ones. Let's say a skin cell or an endothelial cell, lining the arteries and veins, or a melatonin, the coloring cells in the skin. Contain melatonin. So all these cells are being, it's the same DNA that's being decoded. But anyway, I'm rambling. And then you get it down to, Crick and Watson, and then the cracking of the genetic code and the three nucleic acids standing for one protein. I mean, not one protein, one amino acid, and then, in a different combination of three nucleic acids standing for a different amino acid. Amino acids being the building blocks of proteins, and even without, and you describe it, and it sounds like a little computer.
Right.
It's like reading off this code and then going to the little ribosome factory and then taking the code and stamping out these proteins, which are these stamping out these the little units that are snapped together like beads to make proteins, and it sounds like this computer.
Yes,
or a computerized factory, and yet, if humans didn't exist, and there were just unconscious creatures, their cells would still be doing this. Or even if we had existed and never figured this out, the cells would still be doing their stuff without knowing what nucleic acids were, or that G goes with C or A with T, or. I mean, does that make any sense? Or
yeah, well,
it's just for some reason I find that kind of baffling. The cell doesn't know, that it has a nucleus, it has mitochondria and ribosomes. It doesn't know that, that three nucleic acids, stand for a protein unit. And
yeah, it's well. Then you do get down to the question. I mean, what I love about this, and by the way, I want to make it clear, and I did say this in my piece, that I found this workshop mind blowing.
Oh, yeah.
I thought it raised all these questions, like the one you were just expressing, which I think, you know, I'm not crazy about speculation over whether protons are conscious, but I love speculation about whether a bacterium might be conscious, or even have something that that you might call free will. And it gets what I kept remembering at the workshop was something that we've definitely talked about, was the it from bit concept of John Wheeler, who was inspired, as I recall, by his interactions with some of the Santa Fe people to come up with the it from bit idea. And it was, going back to information theory, Shannon defined a bit as a bit is the primary unit of information, and it's either a 1 or a 0 in a digital numerical system. And Wheeler, and his wonderful physics for poets way, says that a bit is the answer to a yes or no question. And again, what I love about that is that we're not talking semantics there, the meaning of the question, but a question has been asked. The answer is yes or no, and that's a 1 or a 0 in a digital system.
Here or there.
Yeah, and Wheeler pointed out that quantum mechanics also, in this kind of vague way that is still very much debated today, also seems to be posing questions of reality. That so the famous two-slit experiment in quantum mechanics, the answer depends on what question you're trying to answer, or how you set up the experiment. And so Wheeler was suggesting that there seems to be that the information theory and quantum mechanics together seem to be suggesting that there is an observer somewhere in the system always. It's required somehow. So what the hell does that mean when you're talking about the world before the appearance of humans, or physicists and information theorists, for that matter?
Yeah, so the RNA, the messenger, or the transfer RNA and the messenger RNA, so the RNA is reading, the DNA code, and yet it's also reading little bits and pieces and then editing it and moving it around into different arrangements. And then it's taking this in a way, the ribosome is reading this information to make its amino acids, to make proteins. And they're doing these things, and we describe this all metaphorically, but we can't help but think of these as being conscious processes.
Well,
and yet they'd be going on even if there was no one had ever written down the code or perceived it. It would just be happening because of intermolecular distances and valences of atoms and all these things that you could describe without using without using the genetic code. It'd be this extremely complex molecular detail down to the quantum mechanics of a cell, say, making a certain protein, or copying its copying the information in its nucleus to make 2 cells. You could describe this all on the most nitty-gritty little quantum mechanical, orbitals of atoms kind of way, and it would just be overwhelming, and no one could possibly understand it. And you just have to sit back in awe that the cell is doing this. And so the fact that we've come up with the genetic code and all of these variations and enhancements on it shows that we've been able to reduce it. We've been able to compress it to a somewhat more comprehensible description, but that has nothing to do with whether the processor itself is working. So does this mean that there's information being transferred actually in the system, or is the information just the way we think about it in this shorthand way? In which case, what you're saying seems to be true, that you do have to have an observer and a consciousness, or is it that this reduction and this reduction in compressibility is something that's not just that human conscious minds do, but that's just basic in the universe and is measured by phi.
Well, here, so what I love about this stuff is, I mean, one of the most profound questions that I think came up at least implicitly at this workshop again is, what is really the difference between biological systems and non-biological systems? And one way I think about it is consciousness is problematic for various reasons. One of the ways I think about it is that biological systems have desires, and the fundamental desire. Again, it's a very anthropomorphic term, but I think you can make sense of the word desire as applied to a bacterium because it desires to make copies of itself. I mean, that's the fundamental. That's what defines something as being biological. That it has to reproduce somehow, and it reproduces with alterations, but it's got this drive to endure and make copies of itself that you don't see in non-biological systems.
Yeah, and to seek nutrients, and like following a gradient of increasing glucose in what appears to be this very determined way, but you can describe it, fairly mechanically too. But there's people like this is one of the things that that Stuart Kaufman has spent much of his life thinking and writing about, and referring to things like the bacterium as an agent.
Right.
There's something different about agents than there is, about matter that doesn't have agency.
Right.
Yeah.
Well, that's what the panpsychic people are saying, that maybe protons have desire somehow or agency also, although there's no. It's a kind of intentionality or agency that is radically unlike what we see in biological systems, and that's why it becomes somewhat incoherent to me. And those strictly physical systems can be plotted deterministically, whereas there's always this unpredictable element in any biological system.
Yeah, but there is in non-biological systems too.
Yeah.
Unpredictability. I mean, the weather.
Yeah.
And it's. I mean, this whole thing that that part of me actually finds appealing about panpsychism is this notion, and I think I wrote a column about this. I think it was last year about we for so long we've carved up the universe into basically four things. And matter, energy, interacting in an arena of space and time. Mm-hmm. And actually, you can say mass energy, hyphened, interacting in an arena of space time. So you could just say two basic things, and everything is assumed to be explicable on some level, with those parameters, including the human brain. So the vastly accepted assumption of neuroscience and cognitive science is that the brain is no more than its physical self, no more than its physical description, that there's nothing extra. It doesn't become imbued with consciousness, and that that it somehow arises from emergent qualities, from the interaction of all these little parts and these little neurons, and then consciousness emerges like wetness and reflectivity emerge from H2O molecules in mass. And yet talking about emergence is you're just kind of saying something magic happens and we can't explain it, but we assume it's not magic, that this is all explicable within using mass, energy, space, time. And then just the idea that in carving up the universe we left out this most basic component called consciousness.
Right.
I mean, that's really interesting. So the part of me that finds that appealing just says, "Wow, that would just be so great." We'll parse things differently, and it'll make make more sense. And then, but then what is this consciousness? Is it something basic like energy? But then what's energy? And it's just also mind blowing when you get out at this far at the near the edge of what you can know. And it's just so great that these people come together and try to figure this out.
Yeah, and
It's inspiring.
to confuse things even more, we're almost out of time. I did want to mention that just this last weekend I went to another conference at NYU with the title "Is the Brain Bayesian?"
Oh,
So
yeah, Bayesian
Bayes'
statistics.
theorem was this mathematical formula that was invented by a Presbyterian minister
Right.
in England in the 18th century named Thomas Bayes.
Yeah.
And it's a very simple technique for taking the information that you have or think you have about the world right now and then updating it based on incoming information. So it's a probabilistic theory, and it has turned out to be extremely powerful. So there are all these so-called Bayesian techniques now that are used in artificial intelligence and robotics for solving pattern recognition problems, decision-making problems, and it's been so successful that it's become almost like a cult. I've had students at Stevens Institute who are, their religion is Bayes' theorem.
Yeah.
And they think not only that it has all these wonderful applications in engineering, but that it can be kind of a guide to living your life and being more rational. And so
Sounds like there could be a popular science book in this.
Oh, I'm pretty sure there
self-help. I mean,
I'm pretty sure there are a bunch already, and you can find all sorts of stuff online about about Bayes' theorem and how fantastic it is. In fact, one of the leading evangelists for Bayes' theorem is a guy that I talked to or tried to talk to on Blogging Heads. I don't know, must be 5 or 6 years ago, called Eliezer Yudkowsky.
Oh yeah, right. I remember that.
Yeah, he's an artificial intelligence researcher. He's into the singularity. But what's fascinating, and I hadn't realized this until I saw the announcement for this new NYU workshop, is that many psychologists, cognitive scientists, neuroscientists now think that maybe the brain is also using Bayesian techniques.
Oh yeah. I mean, there's this whole, really throughout science, pretty much, there's just this debate over Bayesian versus frequentist statistics, and it's something I've been, trying with not great success to get my mind around. I read there was a chapter in Nate Silver's book. And I keep having this experience. I read, there's a popular book about Bayes' theorem that I read. I can't remember the name offhand. And then the 538 guy, Nate Silver, is that right?
Yeah.
He had a chapter in his book. And, and I read these things and I get, right to the edge where I think I get it, and then it goes away.
Right. Well, that was kind of my experience with integrated information theory too.
Yeah.
The Bayes. So this workshop was really interesting because it was pretty much equally featuring proponents of Bayes' theories of mind and critics of the theory. I'd listened to a proponent talk about all the evidence emerging from all these different lines of research for how the brain uses these probabilistic Bayesian methods for recognizing objects and so under noisy conditions. And I go, wow, yeah, boy, that sounds really convincing. And then, a skeptic would come on and talk about all these counterexamples and how kludgy human decision-making and perception is, and it can't possibly be Bayesian. And I go, oh, well, yeah, that seems quite obvious when you put it that way. And and I came away pretty confused. You know, a lot of it seemed to be about this old problem in artificial intelligence, which comes from the fact that in many ways we're not that intelligent. You know, we screw things up. I mean, our brains are phenomenal at certain tasks, but at many tasks we are, you know, we're obviously quite irrational in the way that we live our lives. I mean, I certainly am. I have to reluctantly concede. And yet, you know, certain things I'm talking to you, I instantly understand the words you're saying, even though that is actually a very sophisticated piece of information processing. I'm looking around me and recognizing objects on this table that my laptop is sitting in, on, you know, all that stuff. Those are very impressive feats of cognition, pattern recognition, and so forth. But in many other ways, obviously, our brains are quite ineffective. And so then the question is, you know, what I came away with from this conference was thinking that probably our brain uses all sorts of different methods for solving different problems.
Yes, it's a kludge.
Yes, it's a kludge, and that we might be inventing new methods as we confront new problems all the time. This is something that I concluded after thinking about a problem called the neural code, which is about how information is encoded in the brain, and how it's processed in the brain. And this is something that Christoph Koch told me, that he thought maybe the brain uses lots of different information processing methods.
That would seem, that it's, it's an accretion, over time, from, evolutionary accretion of all these different little devices and gadgets, and which makes it, ever harder to reduce, and then therefore higher phi and
right.
Yeah.
So I think that the brain is the takeaway for people out there in Blogging Heads land should be the scientists are working on the brain. They've got a lot of interesting ideas, but it's going to be a long time before they figure the thing out. Yeah.
And meanwhile, we just sort of understand what they're doing.
Right.
Although you more than me.
But it's really, I mean, I said this at the end of my piece, and that it's, that it's important to raise the questions more than embracing the answers at this point. And I, I really mean that. It sounds very sentimental in a way, but I really mean it. It going to this workshop made me, like listening to you talk about what happens in a single cell. It makes me go, how does that?
Everything is just so weird and spooky at the most basic level, but that's not what you're supposed to think if you're a science person.
Right. Yeah, I'm struck more by the mysteries.
Yeah.
The older I get, with how little we know.
Yeah. Yeah. That's an inspiring thought.
And we just passed 60 minutes.
Oh, so we did. So, shall we call it a wrap?
Yeah, and happy holidays to you.
Yeah, same to you. Merry Christmas, Happy New Year's, and all that.
Yeah, maybe we'll talk again in 2016.
Sounds good.
All right.
Okay, John.